So next on the agenda is Matt Eland. Matt is a Microsoft MVP, and he's going to be presenting on Mad Data Science. He's also an AI specialist or wizard at Leading Edge. He has a master's in data analytics, is a Microsoft MVP in AI and .NET. He teaches software engineering, AI, and data science, speaks at numerous conferences, is the author in both print and video, and works with the Central Ohio .NET Developer Group. Matt is a phenomenal speaker, and he's very enthusiastic, and you'll definitely see that coming across in his presentation. And so, with that, Matt, the floor is yours. Thank you for joining us.
Thanks for having me. You may have oversold me. I was up a little late last night playing with the things we're talking about, or some of the things we're talking about. But as Sam says, I am a Microsoft MVP. I am literally a professional wizard at Leading Edge, which is still amazing to me. If you're not familiar with Leading Edge, we are a consultancy here in Central Ohio. We help organizations throughout the United States with their software engineering, data, and AI needs. Um, we really thrive in helping organizations that are kind of growing and trying to work at scale, helping them scale up, and really being a partner with them as they are maturing their practices and their team. So I get to build things, I get to teach people, and it's a lot of fun. Now, the wizard part of that is usually the thing that gets the most questions, and that is literally my job title. This is my dear friend Bob, who is out presenting in the community here at our office. But the team, what we get to do is we get to write articles, give kind of just serve the community. One of the ways we do that is through lunch and learns. So if you see something here that's interesting to you or your organization, you want to have us out, give me a call at the end. A little QR code you can scan. But let's talk more about what we're talking about today. So this is actually a talk that I gave first at Kids Mash at Code Mash 20. So I wrote this deck mostly for children, but we're going to be covering this with this in a little bit more depth. So we're going to talk about machine learning. We are going to be talking about voices and speech. We're going to be talking about conversational AI. We're going to be talking about reinforcement learning. So I do apologize. It does look like I'm having some poor network connectivity here. We'll see how well this does. But machine learning is one of the things I really love. There's been some really interesting ways of using machine learning in the past that I've worked on. One of the very first things I did with machine learning was trying to see exactly how late I could sleep in on any given day. I trained a machine learning model to predict the number of minutes that I would need to spend defrosting my particular car in my parking spot, given the previous night's weather predictions. And that actually worked out really well. Saved me a couple minutes of sleep every night. I have a dear friend, Sam Gomez, who's done machine learning to optimize HVAC systems for museums, which is pretty cool. I have solved for world peace by proving that Die Hard is definitively a Christmas movie using machine learning, which was pretty fun. That was literally to settle an argument my wife and I were having, but it turns out it is absolutely a Christmas movie. And then I was giving Disney some advice on how to make Doctor Who actually good again, and I used machine learning and data analytics to sort of illustrate that point, and I came up with a recommendation of bringing back, dear old showrunner, bringing back David Tennant, and wouldn't you know it, shortly after that, Disney pulled the trigger. They went ahead and they did it. So I'm claiming responsibility for bringing back David Tennant. That's all me. And Doctor Who is actually pretty okay now. I'm a fan again, so that's nice. So we're going to see machine learning in action here. I have a data set that I got from Kaggle.com. It's a series of video games and various attributes about the games, and then the price the game sold for and how well it did, its rating. Now, as I was preparing this talk for Kids Mash, I noticed this data set is completely fake. They fabricated all this data, but that's okay. We're not really going to be using this to see if a game should be made or not, but this is a cautionary tale I include excited because I got this data set on Kaggle. It didn't say that the data was synthetic, but the data was pretty clearly synthetic the more I looked into it. So just a word of warning there. There's a lot of good data sets on Kaggle. This is probably not one of them. But with machine learning, you typically will train a machine learning model around some data, and it's going to internalize the relationships in that data, and then it's going to be able to use that to make predictions about the future. So I'll click this button and we'll train a model around our CSV data for our video game ratings, and it's going to have a model with some metrics associated with it. So in this case, it said, hey, we should use a fast forest regression model. That's something that predicts a number, and it should be doing one hot encode for some of its columns, replacing some missing values, doing type conversion. It's basically built a little pipeline using AutoML, which is an automated machine learning framework built into ML.net. And you can see we have some metrics here. So the code for this is actually not that bad. With ML.net, you're going to build an ML context. You're going to give it some data, which I've loaded up into a data frame. That's just really just reading it from a CSV file. We're going to split it into a training data set and a testing data set. And then we create an automated regression experiment. I'm going to say, hey, I want you to run for 5 seconds. Here's the column I want you to predict. I want you to predict the rating that a new game will get. And it's going to spit out a trained model. And we'll be able to look at some metrics associated with that. And once we have that model, we can save it to a zip file. And we can load it up and we can make some new things in here. So I can say, hey, global AI connection jam. And this is going to be a fighting game. It's for all ages. We're going to say it's only going to be an hour long because I think we get kicked out after that. We are hopefully online. We are multiplayer. And yeah, okay. We'll just predict the rating of this game. And it's going to use our trained model to generate a prediction. And it says, hey, it's going to be a really good game. That's great. Now, if I increase our price, that should impact our rating to some degree or another. Where it says, hey, the best games have the best prices, so therefore your rating's going to get even better if you increase the price. So that's sort of showing a limitation of machine learning, because in reality, there's a sweet spot for pricing, but the data set doesn't really reflect that. And so it thinks, hey, the best games are priced higher, so therefore, if you price your game higher, your game will be better. So a little bit of a limitation there. You got to understand the relationships with your data, but that's machine learning, and I really enjoy machine learning. Text-to-speech. We're going to go into computers and text-to-speech. I'm going to mute my mic here because if I don't, it's going to suck for you all. But what we're going to be able to do is we're going to be able to give it a string, and we're going to be able to select a voice, and it's going to generate some audio for us. So I'll mute myself.
Hello there. This voice was generated by AI.
I support many different locales and accents.
And so this is a lot of fun. You can use this to generate audio for your applications. I might use this later on this year for game prototyping. This actually plays it through your speakers when you are running your code, which I actually can't find a good way around that to not play it through your speakers. But you get the raw bytes back from Azure as well, where you can go and save that as a WAV file and then just play that again in the future instead of having to call it to Azure. But it's super easy. You're just going to say, hey, I want a new speech config. Here's my subscription key. Here's the region, such as East US. And here's the voice I want you to use, such as English guy neural. Those are the strings we were speaking there. And we tell it, hey, I want you to start speaking asynchronously, or I want you to speaking, and you can have it kind of wait to complete there. Now, speech to text is the opposite of that, where you can tell it to start listening and it's going to listen to what you say and it's going to stop. That's not going to work for me on this device, but I'll show you the code for it. It's super easy. You're going to create a speech recognizer. You're going to give it that same speech config. You're going to say, hey, go out and recognize once. It's going to listen to you. It's going to wait for a pause, and then it's going to pull back some text and a status. So if you need to get a string from the user's speech, this is a really good way of doing it. And in my experience, this recognize once async is really accurate in detecting when the user stops speaking, which is kind of cool. So text to speech, speech to text, really nice ways of augmenting your applications with a little bit of extra capabilities. I really enjoy those in terms of making an application shine. But we'll segue here in a second. I'm going to pause for a drink from Diet Dr. Pepper and to allow for questions in chat. But we'll talk about generative AI next. All right. So generative AI is awesome. It's made a little bit of news recently with large language models and the like. I come from a time when I was interested in AI for other things, so I like to focus on the other aspects of AI other than large language models because there's so much you can do with AI. But I am continually amazed to the point of my own sleep detriment of what we can do with generative AI and large language models. So text completion is kind of where we were 3-4 years ago, where you would be typing something into your search box, and you'd be typing something into Bing, and it would predict what you're going to type next, and that would be a text completion. But text completion can be more than just that. So I have some simple templates here. So here I have a joke template. It's going to say, tell me a clean joke that will make me laugh. Bonus points if it involves Azure, AI, programming, and or Cleveland, Ohio. So apologies in advance if I snub Cleveland here. And it says, why did the programmer move to Cleveland and start working in Azure AI? Because they heard the cloud coverage there was excellent, both in the sky and in their code. Ow, that hits a little close to home when we just heard that the Columbus is not getting a data center soon. But I would agree. Let's go again. Why did the AI move to Cleveland? Because of the cloud over. Yeah. Same cloud theme, but hey, pierogi. There we go. So it's using its large language model to generate a response. I can't go through this without using the Batman prompt. So here we go. Pretend you are Batman who is pausing a tech demo at the Global AI Bootcamp online conference to deliver a 2-sentence monologue about fighting crime. The fight against crime isn't just on the streets. It's in the shadows of the digital world, where algorithms can be as dangerous as any weapon. And that's about as much as I'm comfortable pulling out the bat voice for this presentation, but hopefully that helped you wake up a little bit. Now, the code for this is not that bad. What we're going to do is we're going to have an endpoint associated with our, in this case, an Azure OpenAI service, and we are going to have a key associated, in this case, with our Azure OpenAI service. We're going to create an Azure OpenAI client, give it those 2 pieces of data, and we'll give it the name of our model or our deployment. And then we're going to call this get text completions. We take in our prompt that's a, hey, tell me a joke about Cleveland and clouds. And it's going to say, hey, I need my chat client. I need to go out and get chat completions. I'm going to create a system chat message with my prompt. That's all I'm giving you. I'm giving you this prompt of, hey, speak in a Batman voice or whatever it might be. And it gives me back some content and some text. Okay? So this is maybe a little more complex than you might expect for just getting some completions on text, but we're going to see this come back to help us in a second here. So conversational AI is what we see on basically every website nowadays. And here we're giving it another system prompt of, hey, you're a silly but helpful AI chatbot at the Global AI Conference. Keep your answer short and friendly. How can I help you today? You can work, please. I'm doing a live demo, which always ends well. Oh, absolutely. I'm ready to rock your demo. Let's make it awesome. What do you need? And I'll tell it, you just did it. Ooh, nailed it. What's next? Oh, great. I love having a partner in Azure. And this is the same code, but the main difference here is that we are giving it the system chat message So this is the prompt of, hey, you're this digital assistant, but we're also giving it our conversational history. So every time that we have something, we're going to store it in a chat message, and then we're adding it to the history, and we give it the complete chat async with our history. So now we are giving the initial prompt as well as the context of everything else. And note that we differentiate between the prompt and the individual history through the use of these chat messages. So different type of message, and that helps it handle everything. So when we're working with any LLM with chat, we're really just working with a prompt and then a series of additional things, and it handles all that through basically the same message coming over, which is pretty cool. We can take advantage of that because if I asked it, let's see, what sessions are you looking forward to this afternoon? It's going to say, oh, definitely AI versus pizza, who delivers faster, which is probably a real session out there, but I don't think it's a real session at this event. So to keep it grounded, there's some things we can do. Retrieval augmented generation is a big one of those. So here I've got a system prompt that's the same kind of thing, but it's got a little bit more detail. So I'm saying, hey, you're part of Matt Eland's Mad Data Science talk. You're a demo. The talk is yada, yada, yada. But then I have this additional details that has all of this information here about what's going on in the conference. So now if I ask it, what talk are you most excited to see? It should. There we go. It's a little bit of a suck up, but it's grounded on the data. Fine. What about this afternoon? What's interesting then? And I'll keep my typo just to show you that it can handle it. And it says, oh, definitely build an agent with Azure AI Agent Service by Veronica. This is funny. I was actually using this in prep for this, and it gave me basically that same response. I'm like, oh, Veronica's speaking here. She's great. So you'll love her. But really what we're doing is we're giving it more context in our initial prompt. This is a bit of a hack for this demo. Normally, you wouldn't necessarily put your additional context in your prompt. Normally what you would do is the user comes in and says, hey, what's the weather like today? And you're talking with a weather bot, and it's going to make an API call out to get the weather for your area. And it's going to look for the prediction around Cleveland, and it's going to inject that into your prompt. You can take that up to the next level by adding in more capabilities. For example, right now, let's say that you wanted to make a chatbot for the Global AI Bootcamp page, and you had a lot of articles, you had a lot of talks out there, and someone can say, hey, I'm really interested in learning a little bit more about speech to text, right? Well, what you could do with that is you can actually generate an embedding out of that sentence. Like, I'm really interested in speech to text. An embedding is basically a really, really, really long array. So it's a really long array of numbers. In case of the models I usually work with, it's 1,500 elements long. But it's basically kind of like a GPS location of that concept of what's interesting with speech to text. And what it does with that embedding is it can compare it to all these other things in its database. And it says, hey, I know all these other things. I got this article here about washer dryers. I got this article here about generative AI. I got this article here about speech to text. And each one of those has its own embedding. And you can kind of compare the distance between what the user asked about and the distance between that thing in the knowledge base. And you can say, hey, here are the 5 closest things in the knowledge base. And then those things basically go right in here, maybe a paragraph from them or whatever, and that makes your bot more able to respond to dynamic things from the user. I've used this with really good effect for helping an organization connect parents of children with special needs to help resources and support resources and the like, because we just indexed all their offerings and all the different capabilities and events and the like. And then someone could say, hey, how do I help my kid who's struggling with this in high school, and it's able to find some really good resources for people. Believe it or not, I am a little bit of a nerd, and some of the things that are fun for me right now include Dungeons and Dragons, because I have some lovely coworkers at Leading Edge who like to play. But my coworkers are kind of lame and they don't play enough. And so what I've taken to doing is actually using this technology to build my own dungeon master. And so what I'm doing is I have a prompt that's telling it how to behave as a dungeon master, and then I have some capabilities that it can plug into. But because I have more than just one thing I can search, so I could search the any number of those Dungeons and Dragons books over there on my bookshelf, um, or I could search the history of the world or our previous chat histories or whatever. I now have a bunch of different data sources, and so I'm moving beyond retrieval augmentation generation and more into AI orchestration, where we now have to select from multiple different data sources. Um, so that's an interesting approach there that helps you learn a little bit more about things, and that I found that very effective for being able to work with a bunch of different capabilities. Any questions before we move on? I am quite a bit ahead of time, I feel like, at this point, because I built this for a bunch of children who were, I was expecting to ask a lot of questions, and happy to answer anything as I take a sip of my sponsored drink.
Again, I wanted to reiterate, if you have any questions or comments, either jump in verbally or through the chat window. We want to make it as casual and as open as possible.
Lovely, thank you. So
far, I don't see anything in chat.
Okay, that's fine. With that, I will jump into my next point here, which is a talking dog. So I do ridiculous things with my time. And one of the things I did several years ago was I took this little dog, this little stuffed dog, no, please don't call PETA on me, and I said, hey, what can I do to teach Azure AI services to the community? And I said, well, wait a minute. I have a little dog. He is a 5-year-old, he's an 8-year-old Cairn Terrier at this point. And he likes to look out the window, spot things in the yard, and he barks. And he listens to me when I'm talking. And so I'm like, wait a minute. He's using vision, he's using speech, he's using reasoning, he's using all these things to behave in a certain way. Boy, wouldn't it be nice if my dog could just lay back and relax and just enjoy his day. And so I said, fine, let's get together a system that I can put out and I can look out the window. And so what I did is I got this little stuffed dog. I strapped a webcam to it. This is actually the webcam I'm using right now, so I can't do that. And I connected it to Azure AI, and it would look out the window, and it would use some of the vision stuff we'll talk about in a minute, and periodically look. And if it saw an animal it recognized, it would respond to it. And the way it would respond is with this conversational AI. So here I've got, you are Doggos, because of course I called it Doggos, a digital AI assistant that thinks it's a dog as part of the Mad Data Science talk. Here's how I want you to behave. Here's what the current date is. And I got that wrong, so let me fix that here. Sorry about that. Yada, yada, yada. So be friendly, keep your answer simple. And I'm going to say, hello, Doggos. Can you tell Azure Cleveland Global AI Bootcamp a fun joke? And I will mute myself so you can hear it without an echo.
Sure. Here's a possum joke. Why don't dogs use computers much? Because they're afraid of the mouse. Paw Print's face with tears of joy. Hope that got some tails wagging.
So I hope that none of you are wagging tails, but this is kind of the experience you can get. You can have this nice little thing. If I was able to have working mic, I could have it listening to me conversationally using speech to text, and so you can kind of have this nice little two-way conversation going.
Oh no, no tails? That's rough. Dog face. Well, hopefully, their laughter makes up for it. Humans can bark a good laugh too, right? Grinning face with smiling eyes.
So I really like this particular voice. This is English US Guy Neural. It's one of the worst voices in terms of condensability on Azure. All of Azure's voices are neural network based, and so they try to emulate human voice patterns. But to me, it sounds just like a dog voice, and it sounds just like Doug from Up, which I always love. By the way, I don't advise carrying around a gun case with a stuffed dog on it in your daily life, unless your organizers know what you were up to. So just a PSA for your own safety there. When I really have this working, I have it hooked up to a camera and it can take a picture and send it to Azure, and it's able to remark on that with the same sort of a prompt. We'll kind of see a facsimile of this here in a second as we go on to vision. But you can kind of see how these things work together. You have the speech helping you interact with the system, helping it interact back with you. You have the prompt orienting it a little bit to how it should behave. And then OpenAI just lets it do its thing. By the way, I think I'm using GPT 4.0 for these interactions. If you were curious, I try to think of models as substitutable as I can, because I think that's the same thing to do, because you can't keep up with all the models coming out every day. And over the course of any application, you're going to substitute your models multiple times, I feel like, if you have a successful application. So image captioning. We don't have images here, so I have some images from CodeMash at Kalahari. What we can do is we can give Azure an image, and this is probably unimpressive at this point, given the things we can do with large language models. But a few years ago, this was pretty impressive. So I can give it this nice little image, and it says it's statues in a room. Okay, a little underwhelming description there. We'll try another one. A room with a large tree and a large screen. So I think it's thinking this is a screen back here, so it's actually wrong. That's just lighting from the overhang. A group of people on a stage. Okay, not the best descriptions, but they are AI generated descriptions. Code for this, super easy. We're going to take our Azure client. We're going to call analyze async. We're going to tell it we want a caption, and we're going to give it the binary data or URL from our image, and then it's going to spit back some text. Okay, super easy, barely an inconvenience. Quality could be better. We'll look at some better options, but it is pretty quick to caption that. You can see this might be helpful if you have a bunch of photos your users have uploaded, or if you have a photo album you kind of want to go through in bulk. It can be really helpful for that. Now, dense captioning is a different animal entirely, no pun intended. Dense captioning is looking at your image and saying what's in it and where. So here we have a statue with a line with a sign on it with 70% confidence, and it's got a region on that, which I'm assuming is this region right here. We've got a bunch of other things in here, a sign with white text, a group of people standing in a room, which is presumably these guys over here. And you can see it's able to find what's in your image as well as bounding boxes for that. And you'll note that there's always going to be one result that's your entire image wide and tall. So this effectively gives you captioning plus object detection in the same API call, which is interesting. So it always gives you one for the entire image. Code for this, really about the same, except you're saying I want dense captions instead of captions. And then we're looping through all of our captions, and we are then just looking at it. Each one's going to give you a bounding box. Each one's going to give you a confidence, which is a value from 0 to 1. I do recommend filtering things out that have low confidence. You're going to have to experiment with this and find out what you like. I find usually 70–80% confidence is a good threshold, but you're going to have to do some experimentation with your types of images. But if you need to figure out where something is in your image, this is a really good option for you. So here is, I would call it the new version of image captioning. Let's take this one here, which we described earlier as a bunch of people on stage, and we're going to send it to our large language model.
Oh wow, this looks like a really fun place. I see some humans jamming out on a stage with musical instruments, lots of noise-making gizmos, like drums and guitars. There are colorful beach umbrellas scattered around, which makes me think this is a potty disguised as a beach vacation. The big screen says CodeMash 2025, but to me, it looks like a squeaky toy conference. Where's my invite? Those chairs and tables would make great nap spots, by the way.
So as you can see, I did hook this up to my prompt for Doggos, and I did hook this up to text to speech. So we have kind of a nice little immersive experience, so you can get a little bit of a sense of what it'd be like with the webcam there. Code for this is entirely different because it's not using the image analysis API, it's using the chat API. So we got our chat client again. We are going to create a system prompt, which is basically, hey, you're a Doggos, respond in a friendly manner, that kind of thing. And then we're going to give it the user's message. And we're going to say, hey, here's the image I'd like you to describe. So this is me saying something on behalf of the user. And then I'm going to create an image part. And I'm going to give it the actual image bytes or the URL. And I'm going to tell it the media type. And it just gives me back text, just like I was doing with anything else, which is pretty cool. So in my experience, this is probably the new way of doing captioning. Captioning is still available. It is cheaper in general, and it's faster in general. But if you need something more rich and nuanced, especially if you can give it a custom tailored prompt, then using an LLM is not a bad idea. There's even specific models that you can use for image analysis that people are trying to use for, let's say, form recognition and things like that. If you do have some serious form recognition needs, for example, a client I work with right now is doing something where people send in proof of insurance from a variety of different providers. My recommendation is not yet to use a large language model for that, though we are getting there. I would instead use Azure Document Intelligence for that because it's literally built for that purpose and it's really good and effective at that, and you get a little bit more control over it. But LLMs are getting there where we can analyze images and get good responses from images. With DALL-E and others like it, we can actually go out and we can generate something. So let's generate, oh boy, a squirrel drinking Diet Dr. Pepper while driving a F1 car around the moon. Why not? The things that pop into my mind are a little alarming sometimes, but we'll see what it comes up with. We're going to send this to DALL-E. It's going to take a little bit of time, and it's going to generate it, and we'll get the image URL back. My application then downloads that, and it displays it here. And that looks a little bit closer to Donato's than it does to Diet Dr. Pepper, but hey, it got the diet color right. And then that is a big honking squirrel, but I can't say I've ever seen this image before, so good job generating something unique and new, Azure. Pretty cool. I always have a lot of fun with these kinds of things. Code for this, we're getting our image client, we're calling generate image async, we're telling it the quality of the image and the dimensions. The size of this, there are only a few supported sizes for this, so you need to do a little bit of experimentation or read the documentation to figure out what you can actually get away with. But it's not as much as you would think. Usually it's 1-to-1. Sometimes you can do a 2-to-1 aspect ratio, kind of like a widescreen thing. But you're basically saying, hey, here's my image or my bytes or my whatever it is. Give me back the URI, and it gives you back the URI. It also gives you back a revised prompt, and I think I'm displaying that here. Am I? I don't think I am. But what it's effectively doing is it's putting your image prompt through a large language model. That's actually kind of refining your prompt a little bit more, so it's being more specific about the image it should generate. And then it's sending that refined prompt into DALL-E. And DALL-E's going to generate the image from it and give you back that image. So you'll get back both the image and the under the hood prompt that it used to make your image a little bit better. So it's a little bit of a secret artifact you get back there. So kind of cool. We are flying through things at this point. So any questions before I move off of Azure and onto just random weird Matt stuff?
Okay,
Yeah. Sorry, go ahead.
oh, this will be a dumb question. Where is it telling it Dolly in your code?
The code would be, there are no dumb questions, and that definitely wasn't one if there were. But that would be the image model name. That's going to be your deployment of your image. So I believe this would be like Dolly 3 is what I deployed it. So whatever you deployed it as in Azure AI, that's the string you're giving it here.
So this is embedded within Azure AI, and image model name is that variable's loaded somewhere else, and that's where it gets Dolly?
Yeah, I'll share my code with you. I'll have a form at the end you can scan to get the code for this, so you can kind of look over all the code in its totality. But effectively, what you're doing is you're going out and you are going to the ai.azure.com, and you are saying, hey, I want a Dolly 3 model. I'm going to deploy it, and now it's going to give you a URL. It's going to give you the name that you gave your model, and it's going to give you your API key. And those are really the three pieces of information you need. The endpoint, the key, and the model name, and then you plug those into the SDK, and it's able to generate the stuff back out to you, which is pretty nice.
Thank you.
Yeah, thanks. Happy to help. And I'll have that at the end here as a QR code, and Sam can hook you up as well, I'm sure, after the fact. And you can connect with me on LinkedIn as well too.
I have a question for you, Matt.
Yeah.
So I used Copilot in the past to generate an image for the user group as a logo, and as I tried refining it, it would basically create a new image altogether. So let's say we take this image that you have now with the squirrel and the race car, and
sure,
just for the sake of argument, let's say you just want to modify the color of the tires, for example. Can you do it so that it doesn't recreate the image from scratch and start with a new image altogether?
Not that I've seen. The capabilities I've seen, at least built into the SDK, are pretty limited in that regard in terms of like iterative or regional things. I would be sure something like that is coming. For now, if I had that kind of a need, I might go with something like Midjourney, which has more tooling built in specifically for that purpose. But I would expect that we would see more capabilities like that in the future, but I don't think that they're present now.
Okay, good. Thank you.
Mm-hmm. And this is a case where it just kind of decided its own art style. So you can give it your own style in a style of Monet painting. Sure, why not? Fun fact, I took art history 3 times in college because I kept having to drop a course, and that was the one I would sacrifice. And art history has come in handy with the new trend towards generative AI for imagery, because I now know what a flying buttress is and all these pointillism and things like that. So being able to describe the images you want to Azure, kind of handy. But it's neat. And this is just a URL. You can download the image. You can share the URL. I'm not sure about the retention policy for these URLs that are generated. I would suspect that there's an end date to it. So if it generates something you like, I would download it. But it is public. You don't have to be authenticated once you have the URI. So cool stuff. You can build a lot of really fun stuff. The nice thing about this, all this stuff I've shown you thus far, is that it's all pretty low barrier to entry in terms of your knowledge and the things you have to know. The worst part of that would be, machine learning, because you have to have like a little bit more knowledge and understanding, let's say, of the process of training machine learning models. But with AutoML, I don't even have to know exactly like what machine learning algorithm I'm trying. It just sort of tries a bunch of different ones for me. If you know a very specific algorithm and how you want to prep things, then you can do that. But the barrier to entry is actually very, very, very low in terms of getting started with things, which is really nice. Okay, so any more questions before we move to our last segment here? I forgot I had a picture of my dog here. So reinforcement learning. Reinforcement learning, I think any pet owner can tell you what reinforcement learning is. or parent, I would imagine. But reinforcement learning is basically, hey, things are going to try some things, and they're going to get a good response or a bad response, and they're either going to encourage those things or discourage those things based on how they work, right? So these examples here are kind of for children, but with reinforcement learning, you are taking a algorithm and you're applying it to a real world scenario, and you're saying, hey, go out and try something and I'll tell you how well you did. An example I really like is people who applied reinforcement learning to Mario Brothers, the game from way back in the 80s. And they're saying, hey, we're gonna look at the screen and we're gonna try some things. We're gonna press some different directions. We're gonna press the A button, the B button, whatever it might be. And we're gonna go for 30 seconds or 2 minutes or whatever. And we're going to give you a score. And actually, Mario gives you a score based on how many coins you collect, how fast your time was, and things like that. So that it has that built in. But we're going to try a bunch of stuff at random, and we're going to get a score for it. And depending on how we did at random, we'll try something else and see if our score went up or down. And so over a lot of time, you can start to develop capabilities to help you understand, oh, these Goombas will kill me if I walk into them. I should hit this jump key. Or if I hit this block here, I get a coin and I get more points. And so reinforcement learning is a machine's ability to look at a system it can kind of understand how to work with and see how well it did, good or bad. Okay? And I read about this in the early 2000s, and I thought it was really, really, really fascinating. Particularly, I read about genetic algorithms, which are a genome-based application of reinforcement learning. And I said, this is a really cool idea. I really want to experiment with this. I don't know what I can do. I was in rural Wisconsin at the time, and so I looked out the window, and I had my dog out in the yard, a squirrel out in the yard, and a rabbit out in the yard. And so I said, hey, let's simulate this. And so what I said is, hey, let's make a simple application where I can have a squirrel that goes around in a digital world, and let's see if I can get my squirrel to get its acorn and then get back down to the tree without getting eaten by the gorilla in this case, because I was doing this at CodeMash, so everything was a gorilla. So here's a case where it lost because the gorilla is going to stay put unless the squirrel or the rabbit gets near it, and the squirrel is going to win the game if it can get the acorn and get to its tree. In this case, this is going to be pretty easy. The acorn is just right there. The rabbit moves randomly, which will be important later on. But here's a case where I am winning. So here I'm controlling all this, which is sort of defeating the point of reinforcement learning. But I wanted to show you the simulation as just a very simple 2D simulation with a few different actors. Now, what I can do is I can say, hey, I want you to go out there and try to see what's good. And we can say, hey, let's say that our squirrel really likes gorillas. It's going to go towards them. And it doesn't like the rabbit. It doesn't like other squirrels. Not that there are other squirrels on this scenario. And it's ambivalent towards acorns and trees. When I run this, it's going to make a beeline for that gorilla, and the gorilla's going to eat it. So it's not a very good squirrel. The reason it does this is because each tile has kind of this attractiveness to it based on its proximity to the things it likes or doesn't like. So if I say, hey, you don't like the gorilla, you do like the acorn, all of a sudden that attractiveness matrix kind of changes, and now our squirrel is going to go down over here. So it's sort of like rolling a marble around a digital world. I don't expect you're going to need to do this for your day job. If you do, please call me because that sounds awesome. But my hope is you're going to understand a little bit more about reinforcement learning. Now, this is the one part of my presentation that doesn't use Azure. ML.NET doesn't have to use Azure, but you can. But I want you to sort of expose you to a bunch of different AI things in this talk. So here is a squirrel that hopefully is going to learn. I'm going to have the squirrel trained for 25 generations, and we're going to take our squirrel and we're going to move from this kind of random brain to something that it finds is a little bit better. It's going to try 25 different generations, and by the end of it, this is the one that it's going to think is the best. And we can see as it goes on, it's sticking with what it's found until it finds something that does a little bit better. And so this is what it's found after 25 generations of simulating all sorts of different squirrels, taking the genomes of the squirrels that do the best, and then kind of crossbreeding them together, mutating some of them with random mutations, creating new random ones. It's doing a bunch of experimentation. And this particular squirrel has figured out it can get to the acorn, and now it's trying to chase the rabbit. So this may or may not end well for the squirrel. The rabbit is random, and this randomness in the rabbit often will help it get to the tree. In this case, the rabbit's kind of scared, and so it's just staying in that corner. We'll try a different world setup. There, the rabbit moved near the gorilla, and the gorilla ate it as a result. And now the squirrel's just hiding in the corner. This is not an optimal squirrel. You can train it for longer periods of time, and I've done that before. So let's see what a slightly more optimal squirrel might look like. I would say this is not a completely optimal squirrel because it's overemphasizing that tree. So a more optimal one might learn to go out and get this. So it kind of depends on how long you've trained it, as well as the random setting of the game. But my point is, if you have a environment where something can go out and see how well it's done at what it's doing, and kind of score itself, it can reward versions of itself. This genome here is kind of basically what we are saying is in the squirrel's DNA, has how attractive or unattractive these things are. It's going to say, hey, this is my best one. Oh, this one's slightly better. Oh, I should use this instead. And it can kind of evolve over time. The code for this is more complex than I would like, so I don't have a code tab here. It is using a library called Genetic Sharp for this, and I will share the code for all of this at the end in terms of a link to a form you can fill out that I will email you the repository. This is all open source. You can also find me on LinkedIn. I will share it on LinkedIn as well. And that will include this whole Blazor application that we are seeing here today. But if this is one squirrel brain, and it's working pretty well, I figured, hey, let's try this out in a larger scenario. So this is a larger world where we have 5 of each type of thing now. And I'm going to load my preset for my best squirrel. And we're going to see, as we go, each one of these squirrels is going to go in its own isolation. We still have that quirk where they're overemphasizing the tree, so I'll adjust that here. And you'll see some of these are going around and they're doing their thing. Most of these are being a little stupid. They're still overemphasizing that tree. So we might tweak this just for demo purposes here. You get a little bit of a luck of the draw with the random setup of the game. That's sort of intentional. But you can see they're all sort of evolving independently. And they're working in their own way. So here's a different setup. They're out doing their thing, and they can kind of find this optimal strategy. They don't learn during the game. You have to kind of pre-train them. There are versions of this you could do that would learn during the game. But one of the really nice things about this is it all works off of a fitness function. A fitness function is basically how many points do I give people for various things. So let's say a squirrel that gets the acorn and gets to the tree gets 1,000 points. Squirrels who didn't get to the tree but they didn't die, let's say we'll give them some points. We'll penalize them if they don't collect the acorns, and we'll penalize them for turns remaining just to emphasize that they should go quickly to the exit. And this is roughly what I did to train this. But then I said, well, wait a minute here. What if I penalize them for the rabbit surviving? And what I found is, well, the squirrels can't attack the rabbits. There's no combat code in this. Something dies if it gets near the gorilla. But what I found is that after a significant amount of training, we were able to find squirrels who found a solution to actually kill the rabbits. We'll see if this world lets me see that. So if you see here, we're kind of seeing some squirrels getting on the other side of the gorilla from a rabbit, and they're sort of starting to herd the rabbits a little bit towards those gorillas. That they're at the bottom in particular. He's moving that rabbit closer to the gorilla by taking away options and scaring him a little bit. And they're over on the right, one just got that. So you can see the system wasn't built to allow for combat, But because I modeled a world and I found ways of reinforcing behavior that I liked, and I was able to customize how I scored things, it was able to optimize for that behavior. It's sort of like parenting, where if you make a rule that every time you clean your room you get $5, eventually you might have some kids who start learning, oh, I should make my room filthy so I can get $5. You're going to kind of accidentally encourage certain behavior. It's the same sort of a system, right? And this blew my mind the first time I saw it, because I didn't think this was even possible, and AI found a solution that I didn't consider was even a viable solution at all, and yet it worked. Hopefully, people aren't out there making digital attack squirrels with this stuff. There are practical applications of reinforcement learning. The biggest practical applications would be in the fields of robotics. Self-driving cars could be another area as well. That makes me a little bit more nervous. But robotics is a really big one, because you have to deal with legs that don't necessarily look like human legs. You have to deal with weight distribution that doesn't necessarily look like human weight distribution. And these robots have to sort of optimize to not get pushed over when something pushes them or kicks them, or being able to cross a divider and the like. And so there's some really interesting applications of reinforcement learning for robotics. I mentioned Super Mario earlier. Games are AI are learning how to play games, which is really interesting through reinforcement learning. Go would be one of the most famous examples recently, with I think it was called AlphaGo over in Korea, that won that tournament, defeated the world champion. I think it was like best 3 out of 5 won that. There's actually a really good documentary on that. But this is reinforcement learning, and I think it's really interesting and powerful. And this is what Matt does with their time. We're going out there and playing with killer squirrels and the like. If you enjoyed this talk, cool. Glad to help you. B, we have more serious talks on a level variety of things that we'd love to chat with you through Leading Edge. So if your organization is looking to learn something, is looking to get better at something, you're looking to experiment with something, chat with me, because we do lunch and learns, and it's a lot of fun, and I enjoy it. You don't have to necessarily buy anything. So what we're trying to do is we're trying to form relationships with the community, so that maybe down the road you can introduce us to somebody who is in need of some consulting services and the like. But that is part of my job, and I enjoy it. I also like sharing my dear friend Bob, because he's a peach. I have my contact information here. matteland.dev is a good place to go for my content. I have a bunch of different blogs, a YouTube channel, several different books, and LinkedIn courses. And then this form here, if you scan that, you'll be able to say how well I did, how poorly I did, what questions you have. And there's also a little checkbox there you can check to say, hey, please send me information about this talk, and I'll basically just send you the repo link for this code. I'll also send it to Sam, and I will put it on LinkedIn as well. But what questions do we have?
I have none. I'm not seeing any in the chat window. Andrew just posted a pretty long post. Real world applications to your game. A drone that has to take inspection photographs of the hardware connection of high tension power lines to the towers. Needs to avoid the power lines, but needs to position itself to take good photographs of the connection hardware. Good point. Very niche market. Number 2, a drone that is activated at the first sign of a wildfire to extinguish the fire. Very useful. Yeah. The drone needs to go directly to the fire, but avoid obstacles along the way. Actually, I think that could be marketed for home use as well, because when you're away, all you're relying on is a reactive alarm system to tell you something's going on. But something like a drone like that would be very proactive.
Yeah, there's a lot more legislation than you'd think around drones, so just be careful with that stuff. Especially if you're doing anything automated. They really want humans in the loop on everything. Constant eyes on is the requirement at the moment.
And I'm sure with the height requirements for a high tension tower, you need some FAA clearance for that, would you not?
Either that or just pay the fines. By the way, this is not legal advice. Don't actually do this. But yeah. I've been looking at AI and the like and reinforcement learning for game dev and thinking, hey, can I create a version of my game that an AI learns to play, and basically finding optimal strategies for my enemy logic and the like, and so you can kind of train that ahead of time and then encode it into the game or update it later in a patch, and just very topical because the game idea I've been noodling around is a roguelike involving an AI as a player character, so kind of fun.
Speaking of apps, that's a pretty cool app that you were demoing, the Blazor app.
Mm. Yeah, I built this for Kids Mash because I felt like slides for kids was probably not going to be a great match. It's pretty simple. The UI of this is all Mud Blazor, which is free and a lot of fun to work with. It's very straightforward to use. So Mud Blazor would be my recommendation for if you need to add like a simple interactivity to your app beyond what you get just with vanilla Mud Blazor. It's not very themed the way I've deployed it, but you can theme it a little bit more than what I'm doing.
Gotcha. Okay. And you said that's open source, and you're willing to make the link available?
Yeah. Just scan this code or find me on LinkedIn, and you'll find the link to that.
Excellent. Very good. All right. Any questions for Matt? Or comments for that matter?
Common question I get: no, I do not take this through TSA. That would be an interesting conversation to have.
Would you mind posting the link in the chat?
I don't have it handy, and I have to go shortly here. But
Okay.
I will send it to you via email. You can put it in the chat later.
Appreciate it.
Then
Yeah.
I'll put it on LinkedIn. I am Matt Eland, and it's been great to be here.
Absolutely. Thank you for joining us, Matt. And great presentation as always. And look forward to seeing you at the next presentation or conference.
Yeah. See you at Star Trek?
Unfortunately not. But I will be plugging that later for others to attend. But yeah,
Okay.
unfortunately, I'm tied up and won't be able to make it.
Well, for those here who speak, including you, the call for presentations at Momentum opens at the beginning of next month. So Momentum down in Cincinnati, good conference. I'm involved with organizing that one as well, and will be open the entire month of May for proposals. The conference is in October.
Excellent. And another key aspect or selling point for going to conferences in Cincinnati, it's only a hop and a skip away from the Bourbon Trail. So two birds.
Nice.
All right. I won't keep you. I know you got to run. Thanks again, Matt. Appreciate it.
Yeah. Bye.
Okay. Bye-bye.